Okay, this is the May 2011 A21 question on thermal physics. So this one here is talking about the air pressure inside a car tire is that value 280 kilopascals at a temperature. Then tells us the pressure rises and it wants us to find the new temperature. So this is obviously the pressure law where P1 over T1 is equal to a constant, and that same constant is equal to P2 over T2. Okay, so looking at this is my first pressure, so I'm going to call it P1. Here we have our 15 degrees. Okay, so T1 has to be the temperature in this thermal physics. Temperature has to be in Kelvin. So to change this into Kelvin, I'm going to add on 273. And that's going to give me 288 Kelvin. So that's going to be my T1. It's an arrow. Next up, I've got a second pressure when the pressure rises. So that's going to be my P2. And then we want to find the new temperature, so we want to find T2. Now, a lot of the time people can get really confused, and when they're rearranging this equation, they can mess it up. So what I tend to do is I just want to make life easy for myself. So I'm going to do my P1 divided by T1 first. So 280 divided by 288. And that will give me my constant. So my constant will equal 0.972. Okay, then I'm going to have that equal to P2. So P2 they gave us is 310 divided by T2. So basically I've used this side of the equation to give me my constant, and I can ignore that because I've got my constant and I can just focus on P2 over T2. So looking at if I put it into a triangle just to make life easy, T2 is equal to my pressure 2 divided by that constant. So T2 is equal to P2, 310, divided by 0.972, that constant. And when I type that into the calculator, I get about 318.9. Okay, that is in Kelvin. Now, if the answer was wanting the temperature in Kelvin, I'd leave that the way it is. However, and a lot of the time this happens, they want your answer in degrees. So what you then have to do is just take away the 273 Kelvin from that, and you will get your answer of 45.9. Okay, and that is your answer. So please just be careful when you're doing these thermal physics ones. Yes, they may want your temperature answer in degrees, but you always have to turn your temperature into Kelvin first and then put it into the equation, and then at the very end take away 273 to turn it from Kelvin back into degrees.